Hello everyone and thanks for watching Edupedia World Videos. I am Manish Agrawal and today we will be starting with a new topic called atomic structure. Okay, so again we'll only be dealing with the syllabus based on grade 11th of CBSE board. Alright, but the topics that we'll cover in this syllabus will be standalone. That is, you won't have to refer any other material, any other theory part or books to study those topics. Alright, so let's start. In today's session we'll just give you a quick overview about the topics that we'll be covering. Alright, it won't take much time. We'll just give you a quick review of the topics that we'll cover and plus some requisites that you might need to know for understanding those topics. Alright, so the topics that we'll be covering, first we'll start with the basic topics, that is discovery of subatomic particles like electrons, proton, neutrons. Alright, we'll study how they were discovered and some of their properties so that we can better understand what those subatomic particles are and how they behave. Alright, then we'll move on to atomic models. Obviously, once subatomic particles were discovered, people started making new kinds of atomic models to understand the structure of atoms. So we'll study some of the atomic models that came earlier and which now we know are wrong actually. Then we'll move on to isotopes, isobars, quite theoretical part. You might already be aware of what these are. There are isotones and we'll study all of them. Alright. Then we have electromagnetic waves. This actually is a physics topic, but we need this for understanding spectrum and other parts of our syllabus. So we'll go into a bit detail of electromagnetic waves. At least we'll just cover the definition parts like what is wavelength, what is frequency, alright, what is a wave and such kind of thing. We won't go into the physics numerical part, but from chemistry point of view we'll just study the basics. And then we have Planck's quantum theory. Okay, this is going to be very important and it's very easy as well. Okay, so once we have covered these basic topics, we'll move on to more rigorous analysis of atomic structure, starting with Bohr's atomic model. Alright, now again this model might be wrong, but it covers a major part of your syllabus. Alright, and it is very important, so we'll go into great depth here. Okay, we'll take it from theoretical point of view and also from numerical perspective. Okay, and most of your time will go into learning this. It's quite easy actually. And then hydrogen spectrum. Okay, this is obviously based on Bohr's atomic model. Then we'll move on to duality of matter. Now this is again quite an important topic. Alright, not just from your syllabus point of view but for your further studies as well. If you take up chemistry or chemical engineering or something like that, even quantum physics, then duality of matter is quite essential. Then Heisenberg's uncertainty principle and then quantum mechanical model. So these last three topics, duality of matter, Heisenberg's principle and quantum mechanical model, together they are the new kind of topics, that is they are new to this scientific world. Alright, so but a great deal of study has been done on them, so we know a bit much about them. So we'll go into the details and try and understand them from a numerical perspective, because from a theoretical perspective you might find it very difficult to get a grasp of them at this level. Alright, and in quantum mechanical model again we'll go into details of orbitals, orbits and even electronic configuration and all that, and even shapes of orbits and etc etc. Okay, so these are the topics that we'll cover. Okay, and for these topics there will be some physics involved here, like we will be covering electromagnetic waves, but apart from that, for some derivations like for Bohr's atomic model, at the time of derivation we'll use the formula for centripetal force. Alright, and we'll balance force somewhere over there. Okay, so similarly there might be some other bit formulas and like kinetic energy is half mv square. Alright, so such concepts of physics that we might have to use over here in this atomic structure topic. Okay, they'll be quite basic, so if you have already studied them in physics then you won't face any problem at all. But even if you have not studied them in physics, I will just let you know that this is a topic of physics and you just need to know so and so for us to deal it over here. Alright, apart from that, if you have any other further questions based on those topics, you will find that your physics lectures clears them out quite well. Okay, and apart from those physics topics and some sections of physics, we also need to know about Dalton's atomic theory. Okay, now this again you must have studied in class 9th or somewhere, but we'll just go through it again. Dalton's atomic theory was actually the first substantial theory to give us an understanding about matter and structure of matter. Alright, so obviously now we know that it is wrong, but it's still the some of its fundamental concepts given by this theory. For now, some of the fundamental concepts are quite good, and you can say that they still hold true to an extent. Okay, so let's see some of the points that he postulated, John Dalton. Okay, he said that all matter consists of small indivisible particles called atoms. I'm obviously paraphrasing here, but this means that everything, even your body, your computer, alright, your pen, your walls of your room, everything is made up of indivisible particles called atoms. Okay, so after this he said that atoms of same element are identical and differ from those of other elements. That is to say that if you have, say, sodium atom, then sodium atom will be completely different from chlorine atom. Alright, but sodium atoms from anywhere in the world, okay, whether you buy it at your place or you buy it at some other location, or you go on some other planet and check how sodium atoms are there, so they will be identical. Okay, as long as you have taken the elements, as long as you have taken the atoms of the same element, they will be completely identical. But if you take two different elements, okay, if you take two different elements, then their atoms will differ. Okay, differ in with respect to, say, mass, okay, atomic number and other properties. Alright, next he said atoms cannot be created nor destroyed. Now this again, atoms cannot be created nor destroyed, he said that because according to his postulate, they were the most fundamental part of any matter. So they were indivisible, and indivisible means they cannot be destroyed, and if they cannot be destroyed, they can neither be created. Alright, they are as they are found in the nature. Then atoms combine in simple whole number ratios to form compounds. This actually we studied in the mole concept topic, laws of chemical combination, if you remember. So this formed the basis for all the laws of chemical combination, that atoms combine in simple whole number ratios to form compounds. That is, every matter is basically made up of some or other compounds, alright, and those compounds are actually made of other atoms. So atoms turn out to be the fundamental part of all the matter. Then smallest unit taking part in a chemical reaction is atom. Now this again we know, okay, we studied this in mole concept, that it is the smallest part taking part in a chemical reaction. We saw that atoms are always conserved in a chemical reaction. There is only rearrangement of atoms that goes on in a chemical reaction. They don't get destroyed or formed. Okay, so these are the major 5 postulates that he gave. Okay, obviously he went into details of them and gave some others, but these are what we need to know over here. And why we need to know? Because now we know that these are wrong. Okay, and in this topic, in the atomic structure lesson, we will see how these postulates were proved wrong. Okay, so let's go into merits and demerits of his theory. Okay, so let's analyze it from pros and cons perspective. First, let's look at the merits. He explained laws of chemical combination. Okay, so now we know exceptions to laws of chemical combination, and we know how they are actually wrong. For example, when he said compounds are formed by in simple whole number ratios. Alright, so that is wrong. Now we know a lot of complex compounds which do not have simple whole number ratio molecular formula. Okay, the molecular formula are quite complex. Alright, so we know this, that laws of chemical combination might not hold true. We also know there are something called isotopes that exist. So again, they do not follow laws of chemical combination, not necessarily. He also explained stoichiometric analysis in chemical reaction. Once he said that atoms are the smallest unit taking part in chemical reaction, we knew atoms can be conserved in a chemical reaction analysis. So from that conservation, we found out about stoichiometric law, we found out about limiting reagent and principle of atom conservation. But now again, we know that it might not be true always. That is, in nuclear reactions, atoms do get formed and do get destroyed. Okay, so new atoms are formed and old atoms are destroyed in a nuclear reaction. But for our syllabus, we'll only be covering chemical reactions which are not nuclear in nature. You have a separate chapter on nuclear reactions which you will study in class 12th. So until then, we will always skip nuclear reactions. So as far as we don't concern with them, his postulates were quite true. Okay, and again there were several other merits to his postulates, especially that he identified atom as a fundamental quantity, and it is actually quite fundamental, just that we now know that it can be further broken into subatomic particles. Okay, and so let's go into drawbacks or demerits. Existence of electrons, protons and neutrons. Again, the same thing, that atoms is not the fundamental particle. There are subatomic particles called electrons, protons and neutrons, and these are the particles that we'll analyze in our atomic structure. Okay, in fact, after in this atomic structure we will only focus upon subatomic particles, but after that, if you go for further studies, you will see that even protons, neutrons, even these are made up of other particles. Alright, so even these can be divided further. So even these are not most fundamental in nature actually. Then another drawback was he could not account for isotopes, isobars. We will not get into details of this until you have studied what is isotope and what is isobar. Once you have studied them, you will see that how they nullify Dalton's atomic theory. Alright, basically isotopes, isobars go against that principle when he said that atoms of same element are always identical and atoms of different elements are always different. So in isotopes, isobars, isotones, we'll see that that is not actually true. Then there are other drawbacks like we have already studied some of them in the previous slide, and we won't go into further details until we have further studied our atomic structure topic. Okay, so this is all we need to know here, and apart from that, some physics concept that we'll be using in our topics and for our analysis, I will explain them to you a little bit whenever we need to use them. Okay, so don't worry about those, and from next session, that is next video session, we'll start with the first topic, that is discovery of subatomic particles. Okay, and then we'll move on to the next topics and so on. So until then, and good luck with this topic. It's quite easy and quite essential. Okay, so please focus and try and score major marks over here. Okay, so and once again, thanks for watching Edupedia World videos.